I'm Reid Wiseman. And I'm Victor Glover. And this is how we pilot the Orion spacecraft. What are the differences between piloting an airplane and a spacecraft? I think the thing that I first think about is on a spacecraft, it's really all about attitude. It's really not about thrust and getting the airplane flying faster. The spacecraft is already going almost 38, 39 times the speed of sound. So we're really controlling the attitude. Where are we pointing? Where are we looking at out the windows? Where are our antenna and arrays pointing?
The software is the primary flyer of the spacecraft. I think that's the biggest difference, especially for a pilot coming into this who wants to get on the hand controllers and put the aircraft or the spacecraft in its proper attitude. In aircraft, the software is really helping the pilot, and I think now it's almost like we're helping the software.
So a couple of things we're going to do on Artemis II, right after liftoff, we are going to detach the Orion spacecraft and service module from the interim cryogenic propulsion stage, which is just a lot of words for our upper stage. During that, Victor will be physically flying with the rotational hand controller, the translational hand controller, and doing station keeping on this upper stage.
This phase of the testing will be to simulate the flying that we would do if we were docking to another spacecraft like our lander or to our gateway. I think we should show you how we actually control the vehicle. So we've been using terms like rotational hand controller. Rotational hand controller, we say RHC for short, and translational hand controller, THC for short. In an aircraft, you would have a stick and a throttle, but it's the things that you put your hands on to control the spacecraft. We will pitch, roll, and yaw. Those are the three axes in each direction. And then we will also go up, down, left, right, in, and out. And we will assess how precisely that we can control the spacecraft. But we mentioned earlier that the main controller of the spacecraft is software. And so the main way that we interact with the spacecraft is our
cursor control device. You're another favorite. I know you love CCD. This thing, it looks awkward, it looks weird, but when you get to use it, it's actually a genius piece of gear, and I know it is your favorite.
Oh, it is. This is our primary way to interact with the spacecraft. And so what it does is it allows us to determine where we put our focus on the display. So I can move the cursor to a certain display, and then I can move the cursor around to interact with certain fields of data.
And it's one of the primary controllers because there are going to be times when we're under 4G, 8G maybe even, and we won't be able to lift up our hands and push the buttons on the displays. So this is exactly how we will do it. There is far more information on these displays than we will need to fly this spacecraft normally. But if a system goes off, if something goes wrong, we can dig down into the lowest levels of the computer of all the systems here, and we can take a look, see what's failed, talk to Mission Control in Houston.
And then right next to the displays, you see switches and toggles and dials. And so we call those switch interface panels or SIP panels. If the rotational and translational hand controllers didn't work, we also have a backup to a set of switches.
Hi, my name is Jeff Summerall, and I work for Lockheed Martin. We're here in the Exploration and Development Laboratory, where we do integrated testing and verification of the GNC flight software for the Artemis program. GNC stands for Guidance, Navigation, and Control. Guidance is basically, where do we want to go? Nav is, where are we? Controls is, how do we get from where we are to where we want to be? This is the software that interfaces with both the translational and rotational hand controllers.
We call this whole stack up the Crew and Service Module, or the CSM. That is the crew module, the capsule, the spacecraft Orion, and then the service module made by our partners ESA and Airbus in Europe. And so this is where the thrusters that will maneuver us on the service module.
My name is Rashid Amikhan. I'm the lead of Assembly, Integration and Test team of Airbus, and we built the European service module in Germany. When the astronaut gives a command to go in any direction, the software is steering every thruster as needed. So it's a balance or a dance between the different engines. So if you provide thrust on one side, you have to counteract on the other side.
And every time you touch the translational hand controller or the rotational hand controller, those thrusters fire. And those thrusters are right near us, and you can hear them bang it. It's like bang, 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 as you're flying this thing around.
And hear it and feel it. And even though it's quite well shielded and that we're in suits and other things, you're still going to hear and feel those thrusters when they fire. It's pretty neat.
I cannot wait until one of us takes controls and just steers this thing around and looks out at the Earth.
We'll be farther from the Earth than a human being has been in a very long time.
Let's go.
As Orion prepares for Artemis II, we've just seen the moment it stops being only an autonomous machine and becomes a spacecraft humans can truly fly. Reid Wiseman and Victor Glover will take the controls in lunar space, testing Orion's displays, responsiveness, and handling during the proximity operations demonstration, one of the most important rehearsals before we go farther. If you enjoyed this, please give it a thumbs up, subscribe, and share it with someone who loves space. Thank you for exploring the universe with us here at Wormhole to Cosmos. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.